So in this video, we're going to talk about multiplying and dividing rational expressions. Remember, a rational expression, rational just means ratio, so like a fraction, and it's just a fraction made out of a couple polynomials. So first of all, I want to talk a little bit about simplifying. Remember, we can't just cancel like these x's because they're attached with the pluses and minuses to, like this is all attached and this is attached. To cancel, they have to be factors. For example, like if I had 1 plus 2 over 1 plus 3, I can't just cancel out the ones here because this is supposed to be 3/4, but if I canceled the ones, I would get 2/3, which is not true. So just be careful, you can't cancel things unless they are factors. So what's often helpful is to factor. I can factor this top expression here. So think about, since it's 3 terms, what multiplies to give you 6 and adds to give you -5. That would be -2 and -3. Leave this on the bottom, and now you'll notice these factors can cancel because it's multiplication. So I can completely ditch those, and all I'm left with is x minus 2. So this all simplifies to just x minus 2. One thing you do want to be careful with rational expressions is you never want to be dividing by 0, as always in math. And so think about, what could I plug in here that would make this denominator the 0? It's pretty easy to see that it would be 3. If you weren't sure, you could just set it equal to 0 and solve for x. So when x is 3, I'm going to have a problem because 3 minus 3 is 0, and then I'd be dividing by 0. So what we often do is we call this restricting the domain. I'm going to say, okay, this whole expression simplifies to this. However, side note, x can't be 3. Because if it were, then this expression would be dividing by 0, and we don't want that. So again, that's called restricting the domain. The domain can be anything but 3, so we're restricting it. All right, so let's try another one that, again, you can't just cancel these x squareds, but if we factor, maybe we can cancel some things. So what multiplies together to give me -12 and adds to give me a 1? That would be x plus 4 and -3. They multiply to give me -12 and add to give me 1. On the bottom, this is the difference of 2 perfect squares. So the way we factor this one is whatever the square root of x squared is, which is x, that goes in the front of both. We square root 16, which is 4, that goes in the back of both. And then you make one plus and make one minus. You'll now notice that I can cancel out the x plus 4's. And I'm left with just this, x minus 3 and x minus 4. Again, I can't cancel the x's, so I'm just done. That's all I can do. Also, if you wanted to restrict the domain on this one, you would need to say, by the way, x can't be -4 or +4. Or we could just write it like that to be shorthand. All right, let's try another one. On this one, it's 2 terms, but it's not the difference of 2 squares. So if I want to factor it, the only thing I can really do is a GCF, and they do both have a GCF. This one has an x, which would leave x plus 3, and this one also has a GCF of x, which would leave x plus 5. Notice now that these x's do cancel because it's multiplication. I can cancel out these x's here, and that'll just leave x plus 3 over x plus 5. Again, if I wanted to restrict the domain, I would have to say that neither of these factors could be 0. Because if either of them were 0, 0 times something is 0, or if this was 0, 0 times something is 0. So neither of those factors can be 0. So basically x can't be 0, and it also can't be -5, because -5 plus 5 would be 0. So now let's actually get to the multiplication and division part. Just as a refresher, to multiply fractions, it's very simple. You just multiply across the top and across the bottom. That would be -5/8. To divide fractions, oftentimes we remember this by saying keep, change, flip. It's like almost KFC. Keep the first fraction, change this to multiplication, and flip the second fraction. So it would be 8/3 times 5/4. And then you still just multiply across the top, multiply across the bottom, and then simplify if you can, which that would simplify. This is how I often remember the whole dividing thing. Dividing fractions is easy as pie. Flip the second and multiply. So here's kind of the steps for multiplying and dividing rational expressions. First, check, can you factor? If you can factor, that often helps you cancel things, so try to factor it first. And then check if you can cancel anything. Remember, if it's division, you flip the second fraction. That works for algebra just as it does numbers. And then you just multiply across the top and across the bottom. So for example, let's say we're trying to simplify this thing. First of all, the dot in the middle really doesn't matter. Really, I'm just going to multiply across the top and across the bottom. So I'm going to have x times x plus 2 over 4 times 5x, which is 20x. I could distribute the x, however, then I wouldn't have factors to cancel. So it's actually better to leave it factored. Because notice I can just cancel out those x's because it's all just multiplication. And now I just have x plus 2 over 20. So that's it. Let's try another one. Let's say I have 5n over 6 times 2 over 10n. Again, just like with any fractions, multiply across the top and across the bottom. So that's going to be 10n over 60n. The n's cancel, and then you just have 10 over 60, which simplifies to 1/6. Isn't that kind of interesting, actually? It doesn't even matter what you plug in for n here. You would always get 1/6. All right, on this one, again, when you multiply across the top, don't distribute things, just leave it in its factored form. So I have 6 times r plus 2 times 4r. The dot in the middle really doesn't even matter. Like, you could almost just imagine, like, just extend this and just like you're multiplying here. Multiply, multiply. I don't even really need to write it out. And so now I'm going to look and see if I can cancel things. Since it's all just multiplication, I can cancel stuff like the r plus 2, like the 6, and now I'm just left with 4r over 20, which simplifies, divide them both by a 4, and you get 1/5. All right, on this one, again, with a dot in the middle, that really just means take this, multiply it by this. Take this, multiply it by this. So really it's just like, pretend that just keeps going almost. Currently, I can't cancel anything, but maybe if I factor, I can. So let's factor. This is 3 terms, so what multiplies to give you -40 and adds to give you -3? That would be, 10 and 4. No. What do you divide it by? 5? Yeah, 5 and 8. There we go. Sorry. So I've still got the x plus 7 from right here. But when I factor this, it just turns into, I'm going to need -8 and +5. All right. On the bottom, this one actually has a GCF of 7. So when I take the 7 out, it just leaves x plus 5. And then I also have the x minus 8. After all that factoring, now I can cancel a lot of stuff. The x minus 8s are the same, the x plus 5s are the same. That's my favorite part, you just get to cross off everything. And I'm left with this. Be careful, those 7s don't cancel. This is an x plus 7, it would have to cancel with an entire x plus 7 on the bottom. So those don't cancel because of the plus. So that's my answer. Again, if you want to talk restricting domain, remember the denominator can never be 0. So if you wanted to restrict the domain here, you would have to say x can't be negative 5, because negative 5 plus 5 would be 0, and 0 times everything would be 0. It also can't be positive 8, because 8 minus 8 would be 0. So if we wanted to restrict the domain, we would do that. All right, let's try a division one now. So remember, keep, change, flip, even with variables. So we're going to keep the first one, change this to multiplication, and then flip the second one. And now it's all just multiplication. So I'm doing this times this over this times this. You may notice right off the bat these 4 ends cancel, so I'm just going to go ahead and do that. And then this stuff doesn't cancel currently, but I can factor an 8 out of this as a GCF, which will leave n minus 6. And now those cancel, and I literally just get 8. So that whole thing just turns into 8. Again, this is another one where it doesn't even matter what n is. It could be anything. It's always going to give you 8. All right. I think we'll stop there. So again, just remember, it works just like normal fractions, but only cancel if they're factors, not if it's addition and subtraction.